Okay, so what we're going to do right now is we're going to use derivatives to analyze these graphs and actually try to graph these. If you're thinking about sine and cos, we know that they're periodic functions, so they're going to kind of go on forever. So when we're looking at this graph, we're just going to consider it between 0 and 2 pi. And then after that, we can extend it either way just by adding 2 pi to each of our points or subtracting 2 pi from each of our points, and it's going to give us the next cycle. So finding the x and y-intercepts are typically how we're going to start these graphs. I'm going to start with the y-intercept just because I think that it is easier. If you think back to the sine and cos graphs, we know that sine starts at 0 and cos starts at 1, and 0 plus 1 is just going to be 1. But we can also just let x equals 0, and then we can have our sine 0 plus cos of 0, and we're going to get 0 plus 1, and we just get 0. So that one's kind of nice and easy. Nothing really too difficult about it. The next one we've got to set. So for our x-intercept, this one's a little bit different just based on the graph. So we're going to let y equal 0, or f at x equals 0 in this case, and we're going to solve for it. What we have to remember, though, is that sine and cos are the same in quadrant 1 and quadrant 3, because they're both positive here and they're both negative here. So those are the exact same values. Now we need to also remember that the only time that sine and cos are equal is when we have the 1, 1, root 2 triangle. Okay, thinking back to special triangles or unit circle. So here we would have sine is positive and cos is negative, so that the opposite signs here. And here, down here, I'm going to write it small, cos is negative and sine is positive. Okay, so when we're graphing this, or when we're looking at this, sorry, to find our intercepts, we're going to let y equal 0, so we get sine x plus cos x. Then we're going to move one of them to the other side, so I'm going to just have sine x equals negative cos x. And it really doesn't matter because based on that unit circle, the negative can flip back and forth and it's not going to make any difference at all. So we know that x is going to be, when we have 1 over root 2, well, 1 over root 2 means that x is pi over 4. So our related acute angle is pi by 4. But we need to know when are they equal in this situation. So when is one positive and one negative? So in that situation, we're looking at this quadrant and this quadrant. So therefore, x in quadrant 2, x is going to be pi minus pi by 4. So we're going to get 3 pi by 4. And in quadrant 4, we're going to have 2 pi minus pi by 4. So for that one, we're going to end up with x is equal to 7 pi by 4. Okay, so we've got our quadrants now. We've got our intercepts. So these are our x-intercepts. Again, we're just dealing between 0 and 2 pi, and this is our y-intercept. Okay, so if we were to start graphing this, down here, we're using this information to graph. So I'm going to start at 0 and 1. And then I'm going to have an intercept at, what did we say? Pi by 4, I believe. 3 pi by 4, excuse me. 3 pi by 4. And another one at 7 pi by 4. Okay, so we're labeling this graph as best we can. We want to make it as kind of involved as we possibly can. So next, find the intervals on which f is increasing and decreasing, and when is their relative extrema. Okay, so we know that x is increasing and decreasing kind of based on our derivatives. So if f at x is equal to sine x plus cos x, what we can do is we can find our derivatives and remember that when we have f prime at x, or the first derivative of f at x, is positive, then the graph is increasing. If f prime at x is negative, then the graph is decreasing. So if we were to take the derivative of this, we know that the derivative of sine x is cos x, and we know the derivative of cos x is negative sine x. So we can look at it this way. So the first thing that I'm going to want to do is I'm going to actually set this equal to 0 so that I can find out where all my relative extrema are. So I'm going to use 0. So we've got that. 0 equals cos x minus sine x. Now, going back, when we rearrange this, this is going to say cos x equals sine x. Well, cos x and sine x are equal in quadrants 1 and 3. Because if I put a negative in front of both of these, it doesn't actually change anything. So we're in quadrants 1 and 3. We know we're still using pi by 4. So in quadrant 1, x is equal to pi by 4. In quadrant 3, x would be equal to pi plus pi by 4. Okay, we're still using that relative acute angle of pi by 4. So here we have 5 pi by 4. Okay, so those are our relative extreme points. So relative extreme. Okay, now all we have to do is find out where is it increasing and decreasing. So I can sub in any point kind of before that to find out what it's going to be. So we're going to have from 0 to pi by 4, from pi by 4 to 5 pi by 4, and from 5 pi by 4 to 2 pi. Okay, because we're looking only between 0 and 2 pi, those are the only intervals that we actually have to consider. So if I were to take my graph, I should actually spread that out a little bit so that we've got a little bit more room. But if we were to look at this, I can sub in a value between those two. So I'm going to have f at, let's say, or f prime at pi by 6. Okay, so if I had pi by 6, we're going to be substituting that in, and it doesn't actually matter if it's going to be positive or negative, or sorry, what the values are. We just need to know what the value is actually going to be equal to. So I can just sub in any value and actually find out what this is going to be equal to. So here we're going to have cos of pi by 6 minus sine of pi by 6. Now I chose these because they're in our special triangles. Now we'll rewrite them out. Got 1, 1, root 2. And this is pi by 4. Then we've got this one just a little bigger. 1, 2, root 3. Pi by 6, pi by 3. Okay, so when we're looking at that, cos of pi by 6, which is here, that looks like, I don't know what that is, but that's pi by 6. Cos of pi by 6 is going to be root 3 over 2. minus sine of pi by 6 is 1 over 2. This is going to be positive. It doesn't actually matter what it is. Root 3 minus 1 is not less than 1, or sorry, less than 0, so this is positive. So we know that this is increasing. Okay, then from pi by 4 to 5 pi by 4, we can sub in. We're going to have f prime at, we'll just choose pi. So cos of pi minus sine of pi. Oh, I don't need to be over anything. So cos of pi is -1 and sine of pi is 0. So this is going to be negative. So this is decreasing. And then finally, 5 pi by 4, whoops, 5 pi by 4 to 2 pi. And then we're going to have, oh, so let's sub in, I don't know, between 5 pi by 4 and 2 pi, we can have 3 pi by 2 is a nice easy one. We get 0 minus -1. That's 1, which is positive. So this is increasing. Okay, so we've got a pretty good idea of what the graph is doing now. We're going to just, so we'll go back to our graph. We know that it's decreasing here. We know that it's increasing. Well, I should have actually gone halfway between here. So we know that it's increasing here, but there's a couple other values that we're going to have to consider there. So we got a pretty good idea. I think I used the wrong number here. It should have been 7 pi by 4. 7 pi by 4. That's okay. What we've actually shown is kind of a few different things. I probably wouldn't use this information when I'm graphing this. I would use what we've had here. We needed to find these relative extrema, which are very important. The increasing and decreasing, I would go to the next derivative and find the concavity of those extreme points. Okay, knowing that this is a sine or cos graph, we're not going to have a point of inflection unless we look at something like tan or dividing sine and cos. So why don't we take the second derivative, because we know the second derivative tells us a maximum or minimum, and really we only have to look at whether it's positive or negative. If the second derivative is positive, then we have a minimum. If the second derivative is negative, then we have a maximum. So going back to our original graph, we've got sine x plus cos x. So we've got f at x equals sine x plus cos x. Then we've got f prime at x, which we did here, cos x minus sine x. Now f here, so we're going to get negative sine x minus cos x. Okay, so we're kind of slowly moving our way through. All we have to do here is find out at our relative extrema. So we're going to check pi by 4 and 5 pi by 4. All right. Actually, I don't know why I put those 7 pi's. Those are 5 pi by 4. The 7 in was our zeros. Okay, so on our graph then, we've got our relative extrema at 5 pi by 4. What are the two values? Sorry. At pi by 4, which is going to be in this neck of the woods, and 5 pi by 4, which is going to be right there, halfway in between those two. So we've got our relative extrema. We can kind of see where the graph's going to be. We know that it is increasing here, it's decreasing here, and it's increasing here. Okay, I've kind of cheated and put those where they're going to be, but that doesn't matter. So going back to this graph, we're going to check pi by 4 because that was from this here. We're just checking our extremas. So we've got f double prime at pi by 4 equals negative sine of pi by 4 minus cos of pi by 4. So if we go back to our special triangles, which we've drawn twice here, we know that this is going to be negative 1 over root 2 minus 1 over root 2. Okay, both sine and cos are positive in the first quadrant, so we've got those are 1 over root 2's with the negatives. So this is going to be a negative. So therefore, max at pi by 4. So we can go to our graph and put a maximum at pi by 4. We could actually substitute into the graph. So f at pi by 4 would be sine pi by 4 plus cos pi by 4, which is going to be 1 over root 2 plus 1 over root 2, which is 2 over root 2. Okay, and we can put that in. It's going to be slightly higher, so this is going to be pi by 4, 2 over root 2, or 2 root 2 over 2, however you want to write it. The graph's starting to take place, so it's kind of looking like this. I think we're able to kind of see that it's going to do this, but we need to find our points and just double check. So we'll go back up here. We'll have f prime at 5. What is 5 pi by, or yeah, 5 pi by 4, right? 5 pi by 4 equals negative sine 5 pi by 4 minus cos of 5 pi by 4. And this is just going to be the opposite here because both of these are negative in that quadrant. So we're going to have a double negative, which is a positive. So negative 1 over root 2 minus negative 1 over root 2. So this is going to be a positive. Therefore, it's a minimum. And we could substitute this in, but just from kind of knowing math and knowing we're just dealing with the negatives here, f at 5 pi by 4 is just going to be the negative of what we had for the other values. So then here, this is going to be 5 pi by 4 and negative 2 over root 2. I think I wrote it wrong in the last one. Yeah, I did. Let's fix that. There we go. And now we're kind of done. You could add 2 pi to any of these values. So right here, we would have 2 pi and 1. Okay, because we can add 2 pi to any of these because it is a cyclic function. This is going to go on forever. And we could find all of our points. Okay, so we're just going to have some Oxford questions for this, so look into those questions.